So that's it. Hello everyone. It seems like wait a minute. Let me check. I'm in live. Hello everyone. Okay, everything looks fine. So what we are going to do? We are going to do today. Okay. So today we are going to whatever. So if you are watching my live, you know that past 3 or 4 days I'm trying to implement this. I was trying to implement this GPT-2 model. So it's you can ask, is it take that much of a time to implement something like a very simple GPT-2 model? The answer is no. But if you are building everything from scratch, it's going to take for a while, right? So if you are using some other framework, like, you know, basically we are building this in Rust. But if you are using PyTorch or for TensorFlow or anything, something, any of those things, um, you can build it in a something like a. If you are good at programming, you can build it in something like half an hour or something like that. It will take you some hours, nothing more than that. But we are trying to build everything from scratch, from tensor engine, grad engine, the graph, basically everything. No other dependencies. No, the only dependencies we are going to have is this random number generator or something like that. Nothing more than that. It's all everything. It's all from scratch. Okay. So, but I think it's going to give us a lot of knowledge about how these stuffs are actually working under the hood. The basic idea goes like this. If you want to master something in a programming field, something like a React or any sort of thing, okay, you need to build something similar to that from scratch. Otherwise, you're you are not going to master that thing. Okay, you can build stuff with it, right? If I'm using React, I can build stuff. I can build multiple products using React. Okay, still, yeah. So that means I mastered React. No, still I'm using it, but still I don't understand the full think about it unless I'm trying to build something similar to it. Okay, if I'm trying, let's say if I build something like a React minimalistic version of React or something like that, it's going to be a very small, but still I can basically understand lots of core things about React itself. Okay, that's that's one of the that's I would say that's one of the very important thing when it comes to learning of any sort of thing, right? In programming space, I don't know about other type of space, science or whatever, but in programming you need to get this. You need to basically train your mind to think in a first principle. Everything. Basically, you need to. If you're okay with the higher level of abstraction, yeah you can yeah you can build expertise, I would say, but still it's not enough, right? If you are using PyTorch for a year or you know multiple years, you are very good at PyTorch, right? You know everything about PyTorch documentation. You read a lot of them, and you know how it works. But still, if you don't build something similar to it or minimalistic version of it, still you are going to miss out a lot of details, in-depth details, which are basically hided by which are basically hided by the you know the programmers who actually building these stuffs, right? So the stuff exists is for the user convenient, and you know what let's say why you are using React. The reason why you are using React, it makes things easier, right? Not only React, right? If you take any sort of thing, like any sort of framework, it's it's simply I would say it simply makes things better, right? Easier and better. That's why we are using it. That's why you are using it, right? If you are building everything from scratch, it's going to be take some time and energy, and it's going to be, you know, it needs some expertise to even build that thing. Okay, so that's why these frameworks and these sort of things exist. But if you want a master specific thing, let's say I'm a AI engineer, or most of the day I'm spending time with this PyTorch thing, and these sort of implementations. I I would say I need to build something like a PyTorch, minimalistic, some amount of it. Is because I'm spending most of the time with the thing. I have to master the thing, right? If I spend, that's how it is, you know. That that's how it should be, right? In order to get better, you need to do something about this. Okay, anyway, let's leave those, and let's just focus on our project. So I think you can see the left side. I created bunch of files, and I basically trying all sort of things. So so that's it. So here what I am trying to do is something basically some sort of a library. You can think of it as like that way. Then once we build this, then we can build GPT-2 in a much easier way, right? So for that, we need this. Okay, so here we have some sort of a custom struct, and it shouldn't be something like this. It's yes. Pins. Okay. And another thing I want to so what are the layers we are going to use in our GPT-2? We are going to use okay, we are going to use linear layer. Let's first complete this block. Okay. Let's leave those things. Okay. What is it? So here we have something like linear, and it should be this is the linear we are trying to build. So this is the linear layer we are trying to build. What we have here is a struct, and we are doing something. Do we need those fields? Seems like we don't need those fields, right? It's because these are going to be, maybe let's just leave it as it is. Okay, so if bias is equal to true, then tensor dots. Okay, so this thing called here, and yeah, we have a created whites. Let's just go with this. Just same thing. It's going to be let's say, let's put in this in size, come out. How? So each of those things need, so each of, so we don't need to send the input size. Output, that's all we need to set. Okay, and where is the file? I'm just, so that's set. Hmm? And then, so if not, this is going to be executed. Save. Basically, I'm not sure how we can write if else, and still I can build stuff with WEIG. So it's Hertz, not watts. Hertz, okay. And it's going to be our tensor and new, right? Size. I'm basically experimenting with multiple languages, you can call that way, because still Rust is not my expertise. Still I'm trying to build some complex thing with it, right? That's how it is. Okay, let's just make this optional. That's how you learn. I'd say that's how you learn. Okay, now when we call this method, it's going to create something like that, okay? Where to put a semicolons, whatever. In the end, uh, as long as things work, nothing to worry about. Okay, so now sort of it's going to be take a input and the bias. Okay, and it's going to be written as self. We sort of write some logic. So now it's all up to tensor. So what we have here? So we have here a lot of things. Actually, we need to, so basically we don't need this stuff. Do we need this? All we need to know gets, so the tensor is the one going to fill the numbers, not us, right? That's just box data.length. So I think we don't need this line. So it's going to be return a tensor. Tensor.rc dot tensor.data. Okay, that's what you are trying. So basically tensor is a wrap around tensor.data. Here we need to change something. So let's just What is the default size? What is the default data type? It's a F32. So I think already we have something here. First of all, how we just some sort of thing for, okay, let's just leave it. I think there is in some yeah, I'm just filling out with the, what is it, if self not true. Hmm. Okay, no problem. This is how, yeah. And another thing, but we need to take care of this. It should be, how can we index them? Actually, what I'm saying is, can we do something like this? Let's assume we can do something like this in Rust. Okay, now all I have to do, we have some sort of a tensor thing, and I think so when we create a model, we need to really, we don't need this file. Say, first of all, delete unwanted files here. I don't like, I want to keep to the trash, into the trash. Okay, what am I working? It's a linear file, and this. So now we have some sort of a thing like linear layer. So what are the things linear layer need to have? The size and the vector, right? So we are, yeah, here we are creating a model, and this model should be now creating the linear layer. Okay, so when a user call linear, it's going to take the size and create a linear layer, which is a tensor type. So what next we have to do is that now that we have a linear layer, so it's first you need to create a layer, then you need to forward it. Mm, that just meaning that access those functions. Okay, linear layers sort of thing. Basically, I'm not sure what next we can do. Maybe we can use LLM for it. Mm, now that we have a linear layer, next what we can do, and maybe what are the other layers? What are the other layers? Adjust. So here we are looking at something called LLMC. This is GPT-2 implementation, and the person who wrote this is Andre Kapati. So what searching here? Start here we have a sort of a casual attention. That's actually he's the one built it. So MLP. What about the zero? Yeah. Is it actually so that's also we need to create, but those are activations, so we don't need to track them for now. I think this is basically fine to experiment. Whenever you call a model, whenever you call a method using model, it need to create that. Next, it need to update sort of, so it let's say serve graph sort of like we need to rearrange this value, reassign this value. So now it's going to be actually, let's just ask if I have a vec of string of um what is the method for string the elements to that oh my god, dynamic right dot push. So the is so let's implement this default trade. Okay, default is going um graph equals to basically dot new. Okay, and okay, so now can we push and create and push at the same time? If I have something like this, can we do something like this? Because already, you know, let's just, no, we cannot do like this. I know that we have a array in it. So now re-initializing it. Let's just ask GPT. Oh my God. I don't know why, but shit. So it's going to be error. I know that, but let's just try stupid things. One of the best way to become smarter is try stupid things. Can you see the error here? Interesting. Uh, self dot graph dot graph dot push. So it's going to be linear. Okay. So this is, so now we need to, okay, okay, now I have a, let's say I have a custom struct. Here you can see the custom struct, right, called model. When this, so now I'm creating, now I'm getting a instance for it, and and this, alright, and this ins instance need to be processed across files. How can I do that? Uh, I think what I think is we need to use this RC and ref. Maybe we can copy this. Okay, and this RC we need to wrap this, right? Let's just ask, how can I do that? Basically, once I create the stack, let's say something uh, uh, string alt x. Whenever other file other files file using this, whenever other file using model, we need to change we need to field instead of creating a new model. Okay, one instance I want to share and modify the same cross files. You don't want to create a new instance each time. Yeah, exactly. Okay, option one. Yeah, that's what I thought. Then make those whenever you create something, actually so we, okay, model instance, so rc dot default. So what, add linear. So we are creating this and we are sending to the add linear function here. Then we are borrow mute, basically borrowing the mutable reference. So first we need to create a that. So then we need to send it to here. So this should be doesn't make sense because this is not what we want. So the user need to do this stuff. Maybe. No. Maybe we can do this. F1.new. So we are, what we are going to return, we are going to return self. Okay, so this shelf is actually needed to send the self Really nothing. What is the difference between this and this? Both of them kind of it's setting default value to this, right? Whenever mod create you create a struct with, I mean, you create a mod type, its field graph already have this default value of vector. So if I'm going to return this, it's already have a default value, right? So whatever. I don't want to assign anything here. So maybe we don't need this at all. But still, let's put this. Oh my god. Let, let's put this in a command, and it's going to be self and graph going to be vec new. So that's it, right? So now it's going to be return self and so now it makes sense, but this should be, so the self should be created something like this. Okay, maybe we can, so we can do something like this. It's going to be return a self, right? And it's going to be RC new, right? Then R, what is this? R of self new, and then model. Maybe we can just return self directly. Is the reason because shit, I still, so it should be RC new and RC dot new and option new. The another thing is going to be just a serve, and that's it. Now it seems fine. I'm not sure there is any side I mean any sort of error here, but what I what I'm what I can what I'm sure about this, the idea, but maybe if you have any sort of error, clear that later. Okay, so that's set. So how it's it so when okay, once you create this okay, once you create this, the pass to the other module. So the model instance that clone should have to send to the other model. This way we can take the instance and change it, but it should be come from the user, but that's not what we want. That's not what we want. So maybe we can do something like this. Self.clone. So when we call, okay, when you are calling the new, it's going to be written self with the RC and RF. So reference counting and the mutable variable, right? So we can get a mutable variable now. So the problem is, so the problem is when we call a linear, suppose you have okay, suppose you created another function, suppose you create another file and created the new layer. It's going to be a new model, not the one, and then you are connecting it. So if you are doing like that, you are basically missing out. Mm, so we need to find a way to connect these two. Otherwise, so in main function we are, let's say we are creating this model and calling the linear on it. Okay, then then I'm basically writing wrote another file called GPT-2, and I wrote the GPT block and everything there. So for that, I'm going to use the model there as well, because that's how I going to call my function linear, call my method linear. But that model is different than this, because you don't because you are creating a separate thing. Now you no longer able to use no longer able to track the graph. You know what I mean? So for that, that's for that we need to so if he going to create another thing there, he need to modify the same model. So let's maybe we cannot maybe we can create a global variable or something like that. Hmm. So let's just ask LLM what what it basically think about this. Okay, I just copy those and you know, here I have implementation, and when user, so now to change this, when user call this, call this, user need to give the model instance. So so the model instance is the one going to have the actual address, so that need to send here. Okay, is there any way we can, actually, so here they use, so yeah, basically they want trying to do is that only that once we create the create create the instance for the struct, for the model, then that instance needed to be given needed to be given to the all the methods, what methods inside it. Maybe we can here user, here you can see that user needed to use this, so use this RC and R option, and I basically implement them in my code for them. All they need to do is, and the another problem is that they need to send this model dot to model instance, and I don't, and I'm not sure user will do that. So instead, what I'm trying to do is that what I'm trying to do is that once I created the instance, then that instance need given to all the methods by default. So no longer the user needed to send document. What do you need? Use thread logger. What is it? What it is? Or static singleton within. Okay. Type as. So create and store singleton instead. Okay, what you're saying. So US, okay. Okay, what you are doing. So we are creating a type alias. That makes sense. And this is the model. Thread local static model instance. Shared model is equal to or of new global singletons too. And then create and store singles init model instance with instance dot get linear row I that through here you would create a linear layer, but we just push graph. So model.init, no need to pass instance. Limitation, this uses thread allow, so it works per thread. fine for most CLI or single thread apps. If you plan to use multi-thread, you need to use so can you explain the code? This is the confusing. This is just alias for convention. Okay. This is the confusing part. Global singleton using thread locker. This create a pre-thread global variable called model instance, and that's going to be a reshell and inside of it shared model. That's going to be optional. It is an optional. It is an optional because the model may not initiate yet. Make it global with a single thread. Safe no needed. So no needed for unsafe or text. We wrap it so we can mutate it any time. So in it, this set up the global model. So model instance is used to mutate the option. I know that given the thread local access. We put a new inside. So some access the shared model instance. Oh my gosh. Access the shared model instance. This retrieve the stored instance. Borrow. Let's look inside. Okay. Paying attention. Pay attention. Oh, so here we are creating another function called get instance, and it's going to be a shared model. Return the shared model and a model instance with. So this thing kind of confusing. Instance dot borrow dot asref dot expected model not initial and clone. This retrieve the stored instance. Borrow let us look inside the okay, and asref gives you we call clone to bump the reference count. If the model wouldn't initialize yet, it panic. Safer development. Interesting. There is a lot of things going on here, but it seems like it will work. Let's just see. And another thing, So add method uses, so linear get instance. This is how we define a method API. You don't take self because there is no self. Indeed, the method grabs the shared model. It borrows the shared model mutable with phi. Okay, where I can just study about this, you know, libraries. Single stand store, create and store single stand instant. Um, I'm sure there is a lot of bugs expected while I'm just copying paste from my AI to my editor, but I need to basically what this exactly doing. And the another thing I want to know is this okay, this makes sense. And this thing here, what we are doing, so instance dot borrow mute, what is this with actually doing? So there is a lot of things we need to, let's just see whether it actually work or not. So here we need to new, we need to send this some, so it's going to be an input, so it's an input size. Output size, and that's going to be a boolean, and it's optional. Okay, that's it. And we need to send this. So it takes input, can we overwrite them, or can we use, for now just let's just leave it like this. Okay, and the bias, and it's by default, and so Now it all should work. Okay. We are creating this. This is the one actually need to be returned. Let's just put this here instead. We need to create, and that's it. So we no longer need to worry about anything. Okay. Where is the main? Let's just let's just take this. Maybe for now, let's leave it like this. Okay, GCC, and um, Can we access? Right, you can see, but still, why am I getting this here? Hmm. Hmm, could not find in the root. Actually, I have that. But I have that, right? I have the file here, so it's in the root file, but untracked. Why this untracked? Hmm, It once did not add get not adding the model. Okay, what is the command? It's the command for to Commit and get. So I put it in a vice versa. My bad. So this is adding 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 a model tree. Get that. Oh, get. Why am I getting this error? What is the problem? I have this. It's kind of a weird error. Why am I getting this? It's because I all okay. I just basically forgot to stuff all. Sorry for that. Um, so it's a boolean. Okay, it's a small b. Just shit. This is what it says. Hmm? Do I need to include those? So okay. Let's just copy this. So we cannot do something here. Should be some true, right? We cannot just show this is expect. Let's just do something like this, and what am I doing? Hmm. These errors are okay, no problem. But associated item not found in model. We do have them, right? Recurrent and linear. Sorry for that. It's so now it is a linear, and not found in the model. This match. Okay, not found in the scope. What do you mean by that? This not found in the scope. So it's true or false, right? We are setting we are actually bias, so that's what it takes, isn't it? So we have a bias, so we need to set this to these errors are redundant. Use underscore unlinked. Okay, use underscore unlinked. So this is okay. Okay, let's just read this. Maybe we can see that later. So I need to give this the equal sign instead of that. But for now, for our testing purpose, look at that, it actually printed. Now it's much more makes sense. On the left, let us okay, but still we need to dive deep into this code. There is a lot of going on, but still let's just make this and let's just leave it as it is and work these things. And then first thing we need to uh, get this done. Okay, so it's um now bias require. We need to take care now. We need to take care of this. So if it is okay, so what are the things do we maybe adjust? Yes, and the weights adjust sensor and I just call the default on the bias. Mm, so this is going to take that. So input size equal to so output size as well, and bias vectors, and then so here what we need to implement tensor.default. Okay. And another thing, if we are implementing this, so it should take, okay, let's just leave it as it is for now. Just take, so that's it, I think. Mm, mm, mm. We are okay implementing this, and we have this, right? So this is should be If I were to if I would implement this in a C, it's going to be a much simple and lot more easier. It's because, but it's going to be still a dangerous. Okay, let's just, so now we are basically, so basically true and okay, I think now it's fine. Then let's just linear. Okay, thing is sort of fine, looks sort of, let's just run this code. So it is going to be a true this code, right? So these I don't need them. We don't have to worry about them. Okay, we basically forgot to change that in. What is the difference between this and this true? I don't know. Look, cannot find a value in the scope. Hmm. Do I need to do this? What is the error? I couldn't. Okay, cannot find the value in the scope. What do you mean by this? Just let's. What the buck? I think there is not of error in insert or us. No. Okay, let's fix everything. There is no field called shape. No, I do have. There is no field called shape. So what is the first here? Missing comma. Okay, first error here. And the second error, not the number of trade ad. Actually, I'm implementing a subtrade. What else? And is there any problem with that? Okay. Now, Norton found this. It's RHS dot day and RHS. Now it makes sense. And okay, that's am I having two of them? No. Add and sub. Okay. Tensor has defined here, but field doesn't exist. Tuple struct, use the appropriate syntax. No field named data. Does not exist. You had. So how I can define this? So tensor data is wrapped by the 10. So this is basically for not, it's basically for data. mode.linear